Hi everyone, my name is Makoma Gerard of EduMath. Now, having looked at tossing a coin and a dice in the previous videos, now in this video we are going to take the combination of the coin and the dice. But hey, before we go in for it, if you're new here at EduMath, consider subscribing and hitting the notification bell so that you can receive the new videos that we make every day. So let us get straight into it and see you there. Tossing a coin and a die. Let's have a guiding exam. A die and a coin are tossed. Find the probability of getting a tail and an even number, a tail and a number not less than 4, a head and a triangular number. So in our solution, first of all, we have to draw the table of possible outcomes before we start answering these questions. So we have a die which has got faces numbered from 1 to 6. So this here is our die. Now we have got a coin. A coin has either the head or the tail. It has two sides. Coin. So this is the coin and this here is the die. Let us start tossing. So when we toss, we can get the head and the 1. Can toss a coin and a die and we end up with a head and a 2. Coin and a die can end up with a head and a 3 and so on. Then we can as well toss a coin and we end up with tail and a 1, tail and a 2, tail and a 3, and so on up to tail and a 6. Now part A, they need us to get the probability of having a tail and an even number. So we can select A to be an event of getting a tail and an even number. So that means A is equal to a tail and an even number. So we are considering mostly this tail and then we look out for even numbers. So we have T and the even number there is 2. We have tail and another even number there is 4. We have tail, another even number there is 6. So this is the set of a tail and an even number. Consequently, the number of elements in this set A is equal to, now we count these brackets here, all the pairs, we have these 3 elements in there. Then from this here, from the table here, we also need to get the number of elements for the possible outcomes. These are possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 possible outcomes. From there, we can now compute our probability. So probability of A, this here is equal to the number of elements in that set A divided by the number of elements in the whole sample space. So this here is equal to 3 divided by 12. And when we simplify, this is going to be a quarter. So we are done with from part A. Part B, they need us to find the probability of getting a tail and a number not less than 4. That means a number that we should get should be 4 upwards going onwards. So we shall have 4, 5, 6. So these are the 3 options: tail and a number that is not less than 4. We shall have tail and a 4, tail and a 5, tail and a 6. So we say let B be an event of getting tail and a number not less than 4. Now we have said B is going to be a set which has tail and a 4, tail and a 5 itself, tail and a 6. Consequently, the number of elements in set B, this here is equal to 3. So probability of getting a tail and a number less than 4 now becomes the number of elements in B divided by the whole sample space, number in the whole sample space. This here is equal to 3 divided by 12. And when you simplify, probability here of B now becomes 1 all over 4. Next, we need the head and the triangular number. Let's see how to get triangular numbers first. So triangular number, we start with 1, which is a 1 there. So the next one is 1 plus 2, which gives us a 3. We have 1 plus 2 plus 3, which gives us 6. We have 1 plus 2 plus 3 plus 4, this giving us 10. So given the set of our number here, the die has its faces numbered 1 to 6. Alright, so that means here we have gone beyond a 6. Our numbers have gone beyond 6. So the triangular numbers that we have in this table are, we have 1, 3, 6. So the next question here, they need us to get a head and a triangular number. So head and the triangular number, we have head and the 1, head and the 3, head and the 6. Those are the possibilities of getting a head and a triangular number. So let me select C. So we have set C, which is a set showing an event of obtaining a head and a triangular number. So this set here is having pairs head and a 1, head and a 3, finally head and a 6. So this here is our set. Consequently, the number of elements in here, we have 3, and therefore probability of getting a head and a triangular number is equal to n of the number of elements in this set divided by the number of elements in the whole sample space. So we substitute here, we shall have 3 divided by 12. When you reduce, this gives us a quarter as well. So we have come to the end of solving this question here. So at this point, I'm going to give one number to you, my dear viewer, such that you can practice the knowledge which we have obtained here. It says, consider an experiment in which a fair coin is tossed once and a balanced die is rolled once. Describe the sample space for this experiment. Yes. Part B, what is the probability that a head will be obtained on the coin and an odd number will be obtained on the die? So my dear viewer, here we are. The challenge is there. Yes. And I want to thank you very much for being part of my audience up to this point. And again, if you are new here at EduMath, subscribe and hit the notification bell such that you can receive the new videos that we make every day. So from us, EduMath, we wish you the best and God bless you.